The earliest flowmeters were volumetric in nature. That is, they measured the volume of the liquid or the gas flowing inside them. If the temperature changed or the density changed or the viscosity altered, the flow reading would be less accurate. Compensation can be done, of course, but the dream was always to measure mass flow directly. Hi, this is Walt Boyes, editor of Control and ControlGlobal.com, with another edition of Back to Basics for the Process Automation Media Network. This edition is about Coriolis mass flow meters. This edition of Back to Basics is sponsored by Hauser, the largest manufacturer of field sensors in the world. Visit www.endress.com for information about products and applications. What we know today as the Coriolis force was first described by Pierre-Simon Laplace, who is more famous for the Laplace transformations, in his treatise on the equations of tides. Then in 1835, Gaspard Gustave de Coriolis described the effect in a paper he titled On the Equations of Relative Motion of a System of Bodies. It wasn't until the 1970s that the Coriolis effect was applied to produce a mass flow meter, and now there are several varieties from various manufacturers. Here's how it works. The flow meter consists of a tube or series of tubes that are set to oscillating. If there's no flow, the tube oscillates uniformly, and sensors at the inlet and outlet of the tube are used to sense the oscillation very precisely. When fluid starts to flow in the tube, there's a twist imparted to the tube. This application of the Coriolis effect causes the sensors to pick up the phase shift that is proportional to the mass of fluid or gas in the tube. The higher the throughput, the greater the shift, which is directly proportional to the mass flow in the tube. A Coriolis mass flow meter can also be used to independently measure density and volume of the fluid passing through it. At rest, the resonant frequency of the tube changes as the density of the fluid changes. This can be used to determine the density of the moving fluid by dividing the mass on the known volume of fluid in the tube. Dividing mass flow by the density so derived gives us volumetric flow. Because Coriolis flow meters are directly measuring mass to a high level of precision, they are very highly accurate in measuring flow and density. This has made them very commonly used in custody transfer applications. Coriolis mass flow meters are provided in sizes ranging from very small, say 1/24 of an inch or 1 millimeter, to greater than 10 inches or 250 millimeters. They come in 1, 2, or even 4 tube designs for a variety of reasons, including controlling pressure drop across the meter and greater accuracy and precision in custody transfer applications. Coriolis meters can be used for both liquids and gases. The principle is the same, but the sensors have to be much more sensitive since the densities are usually so much smaller. One of the niches where Coriolis mass flow meters has found a home is in batching and filling applications for food, beverages, and pharmaceuticals. Special 3A food and pharma grade flow meters are available for this service. Coriolis meters have displaced almost every other type of density measuring device in the process industries, but even Coriolis meters have some design issues. Let's look at some do's and don'ts for applications for Coriolis mass flow meters. One of the very biggest issues is entrained air. There are some designs which are better than others at handling entrained air, but as a general rule, this is a don't application. Coriolis mass flow meters are designed to operate accurately with single-phase homogeneous flow streams. However, they will operate under homogeneous two-phase flow conditions when some solids or gas are presented in the liquid, albeit at a deeply degraded accuracy. Flashing within the flow meter should be avoided because the tube or tubes can become out of balance and cause the flow meter to cease to operate. No rocks in bottles either. Fluid characteristics and properties can have wide and varied effects on flow meter operation. The flow rate of the fluid should be within the accurate flow range of the flow meter. In some processes, corrosion, erosion, and other damage can occur at certain fluid compositions, temperatures, and/or pressures. Fluid composition should be controlled to the extent that the flow tube isn't damaged or otherwise affected by the fluid at its temperature and pressure. Immiscible fluids, such as water and hydrocarbons, can cause degraded flow meter performance. Approach these applications carefully and give consideration to installing another type of flow meter when the liquids separate and the heavier liquid flows at the bottom of the pipe. Consider orienting the flow meter appropriately, like in a vertical pipe. Coriolis mass flow meters should be zeroed at operating temperature and operating pressure. Temperature and pressure variations can degrade the measurement, especially when they are large. A positive shutoff valve should be located downstream of the flow meter to zero the flow meter under process temperature and pressure. The flow meter needs to be installed in the pipe correctly per the manufacturer's instructions. In liquid applications, keep the flow meter full of liquid using appropriate hydraulic design. Locating the flow meter in a vertical riser is preferred for most flow meter technologies, but may not be appropriate for certain Coriolis mass flow geometries. In horizontal pipes, the downstream piping should rise above the flow meter elevation. Don't locate the flow meter where non-condensable gases can collect, such as in an inverted U-tube arrangement. In gas applications, keep liquid from accumulating in the flow meter using appropriate hydraulic design so the flow tubes remain self-draining. Be especially careful with the piping design in gas service. The pressure drop across the flow meter may be significantly less than the pressure drop across the upstream and downstream piping that includes reducers and expanders. Install concentric reducers for each pipe size reduction upstream and especially downstream of the flow meter. For example, if the pipe size is to be reduced or expanded 3 pipe sizes, install 3 reducers in the inlet and 3 reducers in the outlet piping. Make sure you've installed the flow meter with the appropriate number of diameters upstream and downstream. Now, Coriolis flow meters are susceptible to vibration. Not as bad as they used to be, but still. Keep them to locations where vibration is minimal or degradation in measurement accuracy may result. Coriolis flow meters are a significant advance over many other flow technologies, and they can do very valuable things for you, but only if you select the right one, install it correctly, and operate and maintain it properly. This has been another edition of Back to Basics for the Process Automation Media Network. I'd like to acknowledge that material for this video originally appeared in the Consumer Guide to Coriolis Mass Flow Meters by David W. Spitzer and me. On behalf of our sponsor, Endress & Hauser, the world's largest manufacturer of field sensors, I'm Walt Boyes, and thanks for watching.